This is my second version of task 1, and this is register level programming. Actually, I don't want to talk about circuit again because circuit as same. Just those is not added. Let me add plus connected to the plus and the minus connected to the minus. Let's make it minus gray. This one is red. Yes, so the circuits are the same, but code is much more different than before I wrote it. So this is different than the first one. As you can see, the declaration of the pins to the circuit is different. I use DDR. What is 1, 1, 1, 1 and 0, 0, 0, 0? So as you can see, the lights connected to those pins. In the first one, there is 8 pins, and our LEDs connected to first 4 points pins, and it means first one, second one, third one, and fourth one are connected, and it means that the and I will show the connected one as the number 1. So first 4 pins are connected and last 4 numbers are not connected. It means they are 0. So it shows the pins, which pins are connected, which LEDs are connected to which pins. So there is those function. It says int 0 to trigger, and then for any logical change it turns off. This one turns off int 0 and blah blah blah. So there is a gain int state 0. It means the lights are turned off uh, because state is low. Because the low 0 are the same. So let's go to next step is void loop. I use port D to state the lights, and if the state is 0, let's make state is 240. Why 240? In this case, all the lights will change its mode. If it's turned on, it will change to turns off, and vice versa. And I also show the meaning of 240. 214. Why 214? Because LEDs are connected to the fourth, fifth, sixth, and seventh one, and for the calculation, all the numbers there shows like the power of 2. Let's say this one, the first LED is 2 power of 4. This one is 2 power of 5. This one is 2 power of 6. This one is 2 power of 7. And as you can see, all of them, if you bring all of them, if we calculate all of them, we get the result 214, and in this case all the lights will turn on. Let's check the code. We simulate the program. Circuit USB are connected, lights are turned off because state is 0. Let's push the button and all the lights will be turned on. So you can see all the lights are turned on, and when I click, all the lights will be turned off. Let's click. Yes, all the lights turned off. Let's do some change in this code. Let's make it like that. So yes, as you can see, all those three lights are turned on, and except the last one, because state is 100. Uh, I mean 112. It's 112. 111. So sorry, 112. So, is the calculations correct? Yes, 112. So the last one is not connected, is not turned on. It means that just because uh, the last state, I mean 240, is not used in there. If we let's stop the simulation. If we do the same thing to the others, let's say if we use 16 in there, and when I start the simulation, and after that when I click this button, you will see that on the only the first light will be turned on, because others, those others are not will not be working here. So yes, the first one, only the first one is turned on. When I click, only the first one is turned off. Let's stop the simulation and use this one, because we are asked to turn on all the lights. Let's start the simulation again and see that is there any problem or not. I will click this button now. Let's click. Yes, all the lights turned on, and when I click this one, all the lights will be turned off. Let's check it again. I clicked and all the lights are turned off. So this is the second version, I mean the register level programming version of my task 1. Yes, this is all about my task 1, and as you can see, there is no problem. The circuit works well. Let's stop the simulation and recording also.